All right. Thank you everyone for joining. If you're seeing this, it means you're watching the live stream. So as I go through today's episode, please ask any questions that you might have in the chat. I'm going to go through some quick slides and then show you all a demo. And then at the end of the demo, I'm going to circle back and answer all of the questions that you have in the chat. I'm really excited to have you all here. So let's just jump into it. All right. So today's topic is stealing cookies with cross-site scripting. If you do not know what cross-site scripting is, I'm going to give a quick overview, and then I'm going to show you all what we are going to be doing for today's exercise. So cross-site scripting is, the idea behind cross-site scripting is that anywhere there's user input that can go into a website, and if that user input gets displayed on the page, if there isn't proper sanitization that happens, it's actually possible for someone to put in code that will then get executed by any device that goes and loads that page. So it's a pretty important vulnerability to make sure that you mitigate, especially if you're a web application developer. And one thing that gets a little bit confusing when you're talking about cross-site scripting is just keeping in mind the proper perspective of understanding where in the chain the attack is occurring. The attack is not actually occurring on, like, the vulnerability is with the website, the server, but the victim who's actually going to be affected by the attack is going to be an end user, not the server itself. So that's something to keep in mind, that when you're looking at this, the code that you successfully inject with your cross-site scripting is not being executed on the server, it's being executed on a user's browser. Now, another important thing, I mentioned this a little bit, a lot of cross-site scripting can be entirely mitigated by just using proper input sanitization. So if you're a developer, it's best practice to use one of these libraries to do the input sanitization of the user supplied information, so that you don't have to worry about rolling your own solution or doing your own kind of parsing. Just use one of those existing libraries. There are going to be different libraries depending on what programming language you use, but they do exist for any major programming language that that you use for web applications. So I have a screenshot here. In today's video, we're going to be looking at a single page to-do list web app. This is what it looks like. This is currently in the gym if you want to go play around with it in the web application security category. And in this single page app, we have a text box here and an add item button. So, I can type in hello world, I can hit submit, and then if I refresh, I can see I have hello world added there. So all of the existing to-dos are rendered as a list on the page. And, because I said that anywhere where there's user input that gets displayed to other users, what if we put in code instead of just text? Will that actually get saved by the server and then given to any of the end users who try to visit this page? If we try to use this HTML tag, the B tag, that is an HTML tag for bolding text. So this is just a quick check to see if there is any sanitization whatsoever. And if we actually go and submit this, we can see that the text does end up getting bolded, which means that those bold tags were not removed, they were not sanitized from my input, and they are actually being interpreted by the browser when the page is loaded. So that is kind of an indication that maybe there's something here that we could do with a cross-site scripting attack. It could be the case that maybe some safe tags are allowed, like the bold tag. We'll only know when we actually try to exploit this for real. So before I go into showing the process of doing this, I want to kind of map this out conceptually so you'll know what to expect here. And we're going to go over the attack flow. In this case, we've got the attacker, and specifically it's the attacker's browser. Then we've got the server, and then the admin, specifically the admin's browser. What is going to happen in the application we're going to see today is that me as the attacker, I'm going to start by trying to load this page from the server. So I send a request to the server saying, hey, I would like to load the page. Now, what I will then do is that I will put in some JavaScript code that I am going to use for my cross-site scripting attack. And that JavaScript code will then get added to the to-do list. That's what we're seeing here on the right side. And then anyone who subsequently loads this page, when they load the page, they will get their to-do list with number 1, take over the world. That was just what was in there from the beginning. And then they'll get this malicious JavaScript, which is going to execute in their browser. Now, I've color coded this. And so the next thing that you'll see is that the admin will send a request to load the page. This application is configured so that immediately after you submit something on that to-do list app, an admin user will come along and attempt to load that page. And so there's that page load there. But then what will happen when they load the page is that they're loading the to-do list, and that to-do list now contains our cross-site scripting attack. So whatever code we write in these script tags is going to run in this admin user's browser. And what we want to do is force their browser to leak information and send it back into the to-do list app so that we can retrieve it. We need some sort of mechanism to get data back from the admin user. And that's kind of our goal with this attack here. And so when that happens, an automatic request will be made from the admin user's browser. That's what I have here in red as the automatic attempt. And that will send some sensitive information that the admin user has in their browser to the server to put in the to-do app. And that's what this sky ... is going to be. That's going to be the flag that we'll get when we successfully execute this attack. And so that will not require them to actually type in anything into the form and hit submit. That will automatically happen because of our cross-site scripting attack. Now, when we go to load the page to get the flag that we just took from the admin user, we will make a page load request. Something to keep in mind, though, is that this cross-site scripting attack is on the page, and it's going to run for any user that loads this page, right? Whether it's the admin or me or maybe a completely unrelated person, right? Anyone else that loads this page, they will run into the same code here, and they will send their information back to the server. And in this case, we're going to get an automated message that gets submitted to the server. Because we don't have that sensitive information that the admin has, it's going to be a blank. So the server is going to just get another request for like a blank entry in the to-do app. And then after that, the admin is now going to load the page. And then they're going to actually post their sensitive information again, right? Because I mentioned that anytime you add something to the to-do app, the admin user is going to come around to check the new update to the to-do app. And then that's going to cause them to post their sensitive information again. And then this will be a loop, right? Effectively, what's going to happen here is that the act of us looking at this to-do list app is going to cause us to send data to the server to add something to the to-do list. And then that's going to cause the admin to come along and send another post of data, of their sensitive data. And so it's a little bit of, in physics, you have like the observer principle, where like, the act of like measuring an electron actually causes it to like move, change state, right? It's this, the similar idea. The act of us actually trying to load the flag that the admin user posted into the list is going to cause us to put another thing in the to-do list, and that's going to cause the admin to come back again and put another thing into the to-do list. So this will keep going on and on and on. But that's only every time that we refresh, it triggers another action from the admin. So one thing I will ask you as we go through the demo today, just really try to keep track of what is happening on from each different actor's perspective, right? You have the perspective of me as the attacker, what's happening on my side in my browser. Keep in mind what's happening with the server, what the server is doing, and keep in mind what's happening with the admin user. Another thing for this challenge in particular that can be confusing for people is the fact that we don't want people to wait when they try out this challenge. So the admin user is going to load the page immediately after you add an item to the list. There's no pause. It's like immediate, which could give the impression that like the server is actually performing the action. It's actually the admin that's doing that. The admin is coming and loading the page and executing the cross-site scripting attack. It's just happening like immediately, so there will be no delay. All right, so now let's move on to our demo. And I'm gonna have to shift myself around here a couple of times so that you can see me and also the steps that we're gonna go through for today. So I'll move myself here temporarily to the left side, and I'll zoom in a little bit. We're gonna go through the prompt. There is a to-do list app here. That's this web app over here. And there's a flag hidden in the admin user's cookies. So that is our target. We are going to be trying to steal the cookies that the admin user has. The admin user is periodically checking the to-do list app to make sure employees are actively working. Can you extract the flag from them? So, this is already providing some sort of hint that this is a cross-site scripting vulnerability. That is kind of the first question that we have here. What is the name of the vulnerability? But we'll actually be able to validate that when we go and play with the application. And then we're going to be asked to figure out the flag in the admin user's cookies. And we're also going to be asked for the user agent of the account that the flag was extracted from. So this is the user agent of the admin user's browser. So we have our goals here. Well, let's go and play with the web app itself. So I'll move myself back to the right side over here. And we've got a blank to-do list app. I'm going to do what I showed in the slides, where I'll just try a quick hello world. And if I hit enter and I refresh the page, there is the hello world. So that's us adding in a single plain entry. And now I'm going to add some bolded text. And when I add the bolded text, you can see there, that's bolded. And now let's actually go and see how our input is being put onto the page. If I right click and do inspect element here, and I need to dock this so that you can all see it from your view. So if I go and I right click specifically on the bolded text and do inspect, you can see here we have this div. This is a container for information in HTML, and you can see these LIs. LIs list items. So we have these 3 LIs, and I can close and expand them. So the first LI is the take over the world. This is the first thing that was already in the to-do app when we showed up here. And then the second thing in here is the hello world that I just typed out before. And then we've got our bolded text. So you can see here that I typed in, B bolded and then /B. That's exactly what we're seeing right here. So what we're going to do next is we're going to think through, assuming that we can put in script. And instead of just doing something as simple as bolding some text, which is not super interesting, it's nice, but it's not the most interesting in the world. It's not going to actually get us any sensitive information. We are going to try to put in some JavaScript that the admin user is going to run when they load the page. So what I need to do first is I need to figure out if this is even going to work. And so what I'll do is I'll put in a script, and this might get a little bit annoying for me, but a quick proof of concept that a script tag is going to work here is I'm just going to do an alert. That'll give me a little pop-up that I'll have to dismiss when I load the page. Actually, let me be a little bit less disruptive. I'll do a console.log. That way it's not going to be annoying. I'll do a console.log. And if I hit add item, and then I refresh, oh, actually, I don't think that went through. Let me try again. Script, console.log, All right, I enter it in here. Is it not taking? Let me try this again. Okay, so it got added to the to-do list. And then if I inspect over here, you can see here, there's the console.log with the script tags. And if I actually go and look at the log, there's what I just logged right here. So we know that this is vulnerable now. And now we have to remember what our goal was. Our goal is to get the flag found in the admin user's cookies. So this is something that if you don't know how to access the cookies in JavaScript, you can go and play around with this in the console. If I type in document.cookies or .cookie singular, I get the list of cookies in my browser. Now, there aren't any that I currently have, but I know that the admin user has something in there. So this is what we're going to want to steal from the admin user. So I could do a console.log cookie. If I do a console.log cookie, when this runs in the admin user's browser, it's going to put their cookies in their browser's console, not my browser's console. So I need a way to get the data back from them that I can see as the attacker. And it's already handy that we have the to-do list app itself. What if we had the admin user take the contents of their cookies and put it in the to-do list app, and then we can reload the page, and then we can see what their cookies are. So to do that, we need to figure out what actually happens when we try to submit something here with the form. Now, if I go and I look at the source here, I can see there is this static app.js. That is something that we might want to take a look into. Maybe there's something interesting in there. And I'll zoom in a little bit here to make this easier for you all to read. And what you can see is some JavaScript. We have this add item function, and this is the contents of the function. And then below the function, we have a form, which is being looked up, get element by ID items. And then the form, we're going to add an event listener for the submission. So when the form is submitted, it's going to call the add item function. Looking at the add item function, we're going to get the item here, the element with the item ID, and then we're going to get the value from the item, and then we are going to fetch /item post, and then this is going to be a JSON payload, and then you can see here the contents of what we're sending is B2A. If I'm not mistaken, this is this does a base 64 encoding of whatever you send it of value, and value here is whatever's inside the item element. So let's go take a look. Something tells me that this is the item element, and I'll try to zoom in as much as possible here. You can see that this input field has an ID of item. So that ID of item is corresponding to this. And so when I click on the button, when I submit the form, we're going to get the value of this field, and then we are going to make a post request with JSON base 64 encoded value here, and then that's what gets added to the to-do list. So the simplest way that we can take advantage of this, I'm just going to copy the code, and we're just going to make a modification. Instead of sending the contents of that input field, we're going to send document.cookie instead, because we don't care, it's going to be blank. When the admin view user loads this page, their item box here is going to be blank. There's not going to be anything in there. What we really want is to send their document.cookie. And when we do this, we should be able to steal their cookies when they load the page. So I need to do a couple things to make this work. I need to wrap this in the script tag, and then we'll find out if there's anything that we need to do to kind of clean this up, because this is a multi-line, multiple lines of code, and I'm going to submit this into a single line text box, and we'll find out if there needs to be any fancy stuff that we'll have to do to get this to work. So I will hit submit. Okay. All right, that worked very quickly. So I'm going to walk through what just happened here. I'll close this up and zoom out a little bit. You can see here that we've got a couple of blank items in here. If I look at the specific items, we will see the items that we had from before. This first blank one is the console.log that we used as a test. The next blank one over here, this is our actual payload, our actual attack that we ran. Then we've got another blank. This blank is probably from when I reloaded the page and it tried to steal my document.cookie, and I don't have anything in there, so it submitted a blank. And then the next one here, this is from when the admin user visited the page, and this is the contents of their document.cookie, which is the flag here. So if I refresh the page, you see every single time I refresh the page, we're getting another blank from me, and that blank is is the attack sending my cookies, which is blank, and then the act of me sending the blank response there in this to-do list is causing the admin user to then reload the to-do list app, and then they submit their flag as a result. So that's what's going on here. When you try this for yourself and you're kind of wondering like, hey, how come every time I refresh the page, it keeps getting longer and longer and longer like that? That's why that's occurring. And at some point, when the list gets too long, I think it's usually about 25 items, it will reset, hopefully. So hopefully it doesn't get out of hand for you when you try it. So I'm just going to go and try to submit that as my answer here, and hopefully we get some good credit for that. So the first question, what's the name of the vulnerability? This is cross-site scripting, which we confirmed when we were able to get the console.log to work. And then what is the flag found in the admin user's cookies? And so there's the flag. I've got that. And then we're being asked, what is the user agent of the account the flag was extracted from? So now we need to do a little bit of Googling, because we need to figure out how do we get the user agent. So if I go to trusty old Google, let's figure out how we do this. How do I get the user agent for my browser in JavaScript? Now we're saying for my browser because this code is running in the admin user's browser. It's running in ours too, but like we care about the admin user. So we can see it's navigator.useragent. So I'll go back over here, and then we'll just make a small tweak when we do our payload. When we do our payload with the fetch, we're going to have our script, then we're going to have our fetch, then we're going to close our script tag, and then instead of sending value, we're going to send navigator.useragent. Okay, let's try this. Sometimes, oh, it reset on me. Okay, so like I said, this is also running as on my machine, right? So this is my user agent that's getting displayed here. This is the user agent for Chrome. But also we see the user agent, this Liber8 XSS bot here. This is the user agent for the admin user. So now we have completed the last part of the challenge. So hopefully that was is pretty valuable for you all to kind of see the process and the flow of how these attacks work. I'd highly recommend you go and try this out for yourself. And if you're getting stuck trying to understand how this is working, go back to look at those slides and keep in mind the perspective of what's happening on my computer as the attacker, what's happening with the server, what's happening with the admin user, because the context of where's the code running is probably the hardest thing to track when you are trying to solve a challenge like this. So let me go and take a look at the chat and see what questions you all have. Okay. If you put some text in your cookies on your computer, will this text appear instead of the empty line? It should, and we can actually, I'm doing this live, so it's not going to make it into the recording, but we can try that out. So if I open my developer tools again and I go all the way to application over here, you can look at your cookies. You'll get a list here. Right now it's blank. Two things that we can do to add cookies in here. You should be able to do document.cookie equals, and then this is like the key value pair. So if I just do test equals 1, 2, 3, hopefully that gets saved. If I refresh, I have test equals 1, 2, 3. Perfect. Now this is still got the cross-site scripting just for the user agent. So I'm going to have to get the, we're going to have to regenerate the cross-site scripting attack for the cookie, but that should not be difficult. So instead of value, we're going to send document.cookie. Oops, what am I missing? Oh, right, I'm not putting it in here. I'm supposed to submit it into the list. If I submit it to the list, we've got a blank. That probably is the script itself. And you can see here, we've got, because right now we've got two cross-site scripting attacks happening concurrently. We have the one for the cookie and we have the one for the user agent. We get both happening at the same time. This is my user agent and this is my document.cookie. And then this is the admin user's user agent, and this is the admin user's document.cookie. So, to answer the question here, is it possible to put some text in your own cookies on my own computer here and have that show up instead of the empty line? Yes, that's exactly what we just did with this test equals 1, 2, 3. All right, other questions? Anyone else in the audience? There was an earlier question I saw here. Are challenges different every season? The challenge for the NCL season, the challenges in the individual game and team game are completely new every single season. For the practice gym, that is kind of like an additive thing. So we will go in and we'll add additional challenges into the gym. This is one that we just added this season. And then for the practice game, those use past challenges from other seasons of NCL. So expect that in the gym, in the practice game, those are going to be challenges that have been around before. And then for the individual team game, those are completely new. Okay, Andrew's mentioning that they are having issues submitting to the to list. Is this server side? Could the browser be the issue? I've seen that like sometimes it can be weird. If you're having trouble with this, try typing in what you want to submit and hitting enter instead of clicking on the add item button. Or if hitting enter is not working, do the reverse. And then after you do either one of those two things, refresh the page. This thing is set to reset regularly just because like you run into issues where there's too many items in that list. And it could be that like part of the resetting is kind of affecting you in that way. All right, Danya's asking, what happens after this data is captured? That's a very good question. In the real world, there's a lot of impacts to this. So the number one impact, which in the real world, this would be a website that people could like log into, for example. One of the key things that is stored in document.cookie is the ID for your active logged in session as your user on that website. So let's just say, for example, that instead of a to-do list app, I'm logged into my bank account. When I log into my bank account, the way that the bank account is going to know who I am is that I'm going to send my username and password to the bank account, and they're going to say, okay, I validated your login credentials. For every single request that you make now until you're logged out, I'm going to give you this ID, which is going to indicate your active session. And that gets stored in document.cookie. That gets stored in your cookies. All your cookies get appended to all of your requests when they're made in the browser. And so if you're able to steal someone's cookies, you could impersonate them. So if I had a session cookie with my and this was a banking app, then the attacker who steals my cookies, they can take that and then they can pretend to be me until that session is terminated. So until you hit the log out button or it automatically expires. This is why your bank account does not let you stay logged in for a super long time without inactivity. That's why you'll probably, like, if you navigate away, it's been 10 minutes or so, you'll get that little marker that says, hey, are you still there? Otherwise, you get automatically logged out, because they want to narrow the window that is possible for someone to steal your cookies. So there are huge implications of having your cookies stolen. And that's one of the big things that you have to worry about with cross-site scripting is having the cookie stolen and having that be used for impersonation. Another big use case, though, is that if you're the attacker and you are able to make requests from the user's browser, I might not even need to steal your cookies. I might actually be able to, instead of making a request to add an item to the to-do list app, I can make a request to your bank to do a bank transfer. And because you're already logged in, that bank transfer is going to happen as you. And there are other mechanisms to kind of prevent this. This is something called, can also be done with something called cross-site request forgery. But if you're effectively able to make a request as one person, that as an attacker, you can make a request as that user, you can do things like that where you can, like, drain someone's bank account. So that's something to be careful about. Right. I think, one more question here. Asking about the types of cross-site scripting. I'm not sure what exactly you mean by the types of cross-site scripting. They're just like different things that you can do with cross-site scripting. So like cross-site scripting is something that, like it's just the act of you being able as a user to get input onto the page that other users are going to be able to, are going to load and then execute the code there. Oh, great question here from Emily. What are the main differences between cross-site forgery and cross-site scripting attacks? So with cross-site scripting, the idea is that the malicious code is being added to the same website that the victim is going to be visiting. So I'm adding a user input to this to-do list app, and it's affecting other users of this to-do list app. Cross-site request forgery is actually, it can oftentimes be a much larger issue because that doesn't require a vulnerability on your site explicitly, like in your user input. So cross-site request forgery is if someone is able to make, if another website from another website, a request can be made to your website and your website will accept that request. Then let's say, for example, the to-do list app here has this, on the to-do list app, it makes a request to bankofamerica.com to do a bank transfer. And it's assuming that, if you're logged into Bank of America and you load this page, that transfer will happen. That is cross-site request forgery, where like any request made from any website to your website is being executed. Cross-site scripting is user input to your website is not being sanitized properly and is now victimizing other users of your site. With cross-site forgery, a completely different website can make a request to your website. It's very similar to how, like, when you go to like the comment section of some websites, it'll be the option to comment using your Facebook account, for example. That's an example of like Facebook, requests to Facebook going to Facebook from a different website. Your browser will support that. The question is, as the third-party website that's being requested, are you going to allow those requests to come in, or are you going to reject them? So in the case I mentioned here with your bank, you probably want your bank to reject a request coming from this to-do list app to do a bank transfer, because that's not a good thing. That's not an authorized transaction. And so typically, to prevent those types of attacks, a token is required in order for that request to be processed. And the only way to get that token is if you're logged into the Bank of America website and you're doing things on the Bank of America site. And if things are happening outside of the Bank of America website, then you won't be able to get that token. And when someone tries to make a bank transaction from this to-do list app to transfer money from Bank of America will say, hey, you don't have the token. I'm not going to process it. So that's cross-site request forgery. Okay, another question here. Can you tell the differences between reflected cross-site scripting, stored cross-site scripting, and DOM-based stored cross-site scripting? I think like the DOM-based stored cross-site scripting can usually be like a subset of one of those two other things. The reflected cross-site scripting is typically where there's something in the URL that gets displayed on the page. So what if I did like, let's just imagine we're Google. Actually, I don't have to imagine. We have Google right here. In the URL, it says, how do I get the user agent for my browser in JavaScript, right? And that shows up on the page here. If Google is not properly sanitizing that, I could put script tags in the URL, and then I can send someone this link. And then when someone clicks on that link, if there is not proper sanitization, they will run the JavaScript that is in the URL. So that is reflected cross-site scripting. The stored cross-site scripting is what we just did here with the to-do app, where the payload is stored on the website itself, right? So reflected is it's in the URL, and then stored it's in the database in the website itself. Sancho's asking, did you say there were sanitizing code that should be used? What would it be? It depends on your programming language. So I could search for user input sanitize in JavaScript, for example. There are some basic functions. So there's escape HTML. So let's just say we tried to do this, and they actually have a cross-site scripting example in here. So let's just say instead of the website over here immediately accepting whatever input that we put in. So in this case, we put in script like this. What it should do instead, and actually the browser is trying to be safe about this, and I think that's like Chrome, like this is Chrome automatically doing something to do sanitization. So this might not be the best example because Chrome's automatically handling it. But if I do escape HTML like this with the script, oops, is escape not in here? I could do URL encode. I know that's another one. URL encode. URL encode. Oh, maybe I don't have it from within here. Well, you would use one of these different functions, and that would sanitize the input. And you can see here that it will like put in special characters that will render on the screen like you intend, but are not executable. Okay. Next question. Oh, okay. Is there a vulnerable web application we can use to follow along in a Skyline account? I've only seen the past competition. If you go to the NCL gym, I'm looking at the NCL gym for this season. You go to web application exploitation. This is a new challenge that we just added today. It's it's medium within web application exploitation. Does cross-site forgery open up vulnerabilities for things like Google single sign-on? It does. Well, like if Google were vulnerable to it, right, then that would be something that they have to worry about. I can assure you that the team that handles Google single sign-on is probably very on top of making sure that they're not vulnerable to this. That is something that they have to worry about. Because otherwise, if you're logged into your Google account, think about all the different things that you can do being logged into the Google account. You can send emails. You can view your email in your browser, which means that there are HTTP requests that will pull up your email. And so if they're vulnerable to something like cross-site request forgery, then someone loading a malicious website can now read your Gmail. That's something that they have to worry about. And with single sign-on specifically, then now it's opening up the window to all other applications that use single sign-on for their login. All right. I think that looks like all of the questions in the chat. Appreciate you all joining us live. If you have any other follow-up questions or you're looking for other advice, please go ahead and join our Discord. That is probably the best way for you to get some feedback from other players and ideas and suggestions. I will pop the banner up for that. That is the link to join the Discord. And we'll see you all next time. Thanks so much.
Woo.